to learn some math. Math.
Alright, now the 7th video. This is about volume of prisms and cylinders. Your learning target is I can find the volume of both prisms and cylinders. Okay, let's get going. Alright, so first let's do some notes here. We've got volume of a prism. Volume is the amount of space inside an object, okay? It's calculated, volume is calculated by multiplying the area of the base, B, with the height, H, of the prism, okay? Of the prism. That's how we figure out volume. It's by multiplying the area of the base, B, with the height, H, of the prism, which is measured as the perpendicular distance between the bases. Okay, it's the perpendicular distance between bases, and we can actually write this as volume is equal to the base times the height. The area of the base times the height. All right. Now there's a principle. It's called Cavalier's principle, and in what that says is that if we have two three-dimensional figures, kind of like the ones right over here, that have the exact same height and have the exact same cross-sectional area. Okay, cross-sectional, remember that's like a plane coming through here. So if it's the same height and the same cross-sectional area at every level, then they are going to have the same volume. They're going to have the same volume then. All right, so it's essentially looking here. What we have here is these two shapes, they look a lot different, but if I tell you that the height of both are the same and the area of the base is the same for both, then you're going to have two prisms that have the exact same volume. That's what Cavalier figured out. That's why this formula works, is you just find the area of the base and you multiply it by the height of the prism. Okay, now the volume, coming down here now, the volume given a right rectangular prism, this is as a specific type, can be calculated by multiplying the length times the width times the height of the prism, okay? Which is length times height of a rectangle is really just the area of the base. So that's all we're doing here, is the volume is calculated by length times width times height. And that's a special type of formula that we can use just for a rectangular prism, since rectangular prisms are a little bit more common. Okay. There's also another type of common one, and that's to find the volume of a cube, and that's calculated by cubing the length of an edge, S, okay, if that length of the edge is S. Since a cube has all three sides the exact same, we can just cube the length of a side. So if you have a cube, the volume is just equal to S cubed. That's it. Alright, example 1 here, we have this a hexagonal prism shown here, and we want to find the volume of the figure and round our answer to the nearest hundredth if we need to. So remember, the volume of a prism, since this is a hexagonal prism, the volume of a prism is given by base, the area of the base, times the height of the prism. Alright, so all we have to do is just substitute numbers into this formula and then solve. Okay, so we're going to start by doing that. The area of the base, which we actually don't know the area of the base, we have to figure that out. And the actual shape of the base is a hexagon, so what that means then is we have to use the area of regular polygons formula, which remember is just 1/2 times AP. Okay. Now A is our apothem, P is the perimeter, and so the apothem we see is actually going to be 9.5 miles. And our perimeter, each side length is 11. 11 times 6 is 66. So all we have to do here is multiply this out. 66 times 1/2 is just 33, times 9.5. If we use our calculator and we multiply that out, we end up getting 313.5 miles squared, because we're talking about area. Okay, that's the area of the base. Now we can use that number and plug it into this volume formula. So our base is 313.5, and multiply that by the height of the prism. Now the height from base to base is 9 miles. So we have to just multiply that by 9. And if we end up doing that, what we end up getting is 2,821.5 miles. And here's the difference now. We are using 3 different dimensions in order to figure out what the volume of this shape is. We're using the for this one the apothem. We're using the actual whole perimeter, and we're using the height of the actual hexagonal prism. And so what this is this is to the 3rd dimension. Volume is cubed. Okay, so our volume is 2,821.5 miles cubed. Okay, let's do example 2. It's the same type of deal here, except now we're finding the volume of a rectangular prism. Now, remember, rectangular prism has that special formula we can use, which is length times width times height. Okay, what we're given here is that the rectangular prism measuring 6 meters and 2 meters along the base, and it's 12 meters tall. All we have to do is round our answers to the nearest hundredth if necessary. So we just have to plug in those numbers here. Our length, one length is 6. One length, or the width, is going to be 2. And the height is 12 meters. Okay, 6 times 2 is 12. Times 12 is just going to be 144. Therefore, our volume of this rectangular prism is 144 meters cubed. Now we're also going to try and find the volume of a cylinder, okay? And the volume of a cylinder is calculated by multiplying the area of the base once again times the perpendicular height of the cylinder, okay? So again, what that is that's just volume times the base times the height, which is no different than what the volume formula for a prism was. The only difference, though, is that we can kind of break this down in a little bit easier, right? Because every single cylinder has a base of a circle, and so instead of using B times H, we could write volume as pi r squared times H. And the reason why we can do that is because pi r squared is the area of the base. That's the formula. Pi r squared is the formula for the area of a circle. Okay, let's do an example real quick on this. Example 3 says to find the volume of each figure and round our answer to the nearest hundredth if necessary. Leave your answer in terms of pi for answers that contain pi. Alright, so we're going to use that formula, and I like to use this one right over here because it stays consistent. Volume is equal to pi times radius squared times the height. Now, all we have to do, again, is just substitute numbers into this formula. We have pi, our radius is 5 inches, squared, times our height of 8 inches. Alright, and all we have to do then is just simplify this. 5 squared is 25, and we can reorder this too. Multiply it by 8, and then multiply by pi. 25 times 8 is going to end up being 200. And so we end up getting our volume to be 200 pi, and then we got to label it inches cubed. That's the total area inside of this cylinder, is 200 pi inches cubed. Let's do another example. Alright, example 4 says find the volume of a cylinder with a diameter of 16 kilometers and a height of 7 kilometers. Round our answers to the nearest hundredth. If necessary, leave your answers in terms of pi for answers that contain pi. Alright, so we are trying to find the volume of this cylinder, and remember we have volume is equal to pi times radius squared times the height. And our radius, first let's plug in our information. Our radius we know is going to be half of the diameter, and the diameter is 16, therefore our radius has to be 8 squared. The height of this cylinder is 7 kilometers, so we're just going to multiply this by 7 kilometers. And now again, just like before, this is just simplifying our information. That was the geometry portion of this. Now it's the algebra part. 8 squared is 64 times 7 times pi, and we see that 64 times 7 is actually, if you get your friend out, you can calculate it, it's 448 pi. Don't forget to label kilometers cubed. That is the volume of this cylinder.